In this video we'll be looking at angle units, specifically degrees and radians. You're familiar with degrees. You know that there are 360 degrees in a full circle. You've worked with that for years now. The radians part will be a little new to you. You would have discussed it probably a little in geometry, but we'll be using it a lot here in pre-calc course in the trigonometry section. So there are 2 pi radians in a full circle, just like there are 360 degrees, there are 2 pi radians. And so that's approximately 6.28 radians in a full circle. Pi is about 3.14, so double that, 6.28. The definition of radians comes from a drawing and an associated formula. So if we make a arc length here out of this, and we'll do that. So we have this angle right here, theta. We always use theta, or generally use theta to describe an angle. So the angle there is theta, and this would be just a section of a circle, and so this would be the radius of the circle here, this line, and this would also be the same radius. So those are both equal to r. And then this distance out here, this distance right here, this whole thing, is the arc length. So if you measured that length, if you straightened it out in a straight line and measured it, what would that distance be? That's what that is. Well, theta is equal to the arc length distance divided by the radius. And in the drawing above, r is the radius, theta is the angle in radians, and a is the arc length. So this theta is the angle measure in radians, not degrees. It's in radians. So that's where the radian measure comes from. Okay, this would be true for any angle and arc length and radius combination. Alright, let's look at some examples of this. Okay, example 1 here. In the drawing below, the arc length BC is 20 feet, so that's this distance right there, that arc length. Below the arc length BC is 20 feet, and the radius is 18 feet, so this distance right here is 18 feet, as is this distance. It's both the radius, both are the radius there. Find the measure of theta in radians. So what is this angle right here in radians? So let's write our arc length is equal to 20 feet, and the radius r is equal to 18 feet. So theta in radians is equal to the arc length divided by the radius. We defined that earlier, so that would be 20 over 18, which is 10 ninths. So 10 ninths radians. We'll leave it that way. You could write it as a decimal, but we'll just write it as 10 ninths. So 10 ninths radians is the angle measure of theta in this situation. Alright, let's look at example 2. In the drawing below, find the length of the arc BC, so this distance, when the angle theta is pi over 3 radians. So theta equals pi over 3 radians. And we need to make sure it's in radians if we're talking arc length and the radius and the angle measure in combination, because the definition, this formula, theta equals arc length divided by the radius, requires that that angle measure be in radians. So this one already is, so we don't need to convert anything. And the line segment AC, in other words this radius, has a length of 25 meters. So they didn't tell us the radius, but they tell us that AC, that is the radius, is 25 meters. So we'll fill that in. So we get, what we'll do is we'll just identify what we're looking for here. We're finding the arc length, so we're finding this value. So we'll just solve for that in terms, just get A by itself here. So arc length would be r times theta. We just multiply by r on both sides here in this equation, cancel those. So that's where that's coming from. So if we know that, then, and we know the radius and we know theta, then we can figure out the arc length. So the arc length is 25, let's do it this way. Radius is 25 times pi over 3. So that would be equal to 25 pi over 3, and that would be in, the radius was in meters, so the arc length would be in meters. So that's some decimal value. We'll just leave it like that. If you had a calculator, you could put that in, but we're not using one right now, so 25 pi over 3 would be okay on example 2 there. All right, let's continue on. Okay, now for these angle conversions between degrees and radians. And before we discussed that 360 degrees in one full circle, and there are also 2 pi radians. Therefore, 360 degrees is the same thing as 2 pi radians. Most of the time we'll be referring to this part right here, that there are 180 degrees in pi radians. And you can set up your ratio like this, 180 over pi equals degrees over radians, but most students prefer this setup. So it's the same thing, but this is the way I usually explain it. So if you want radians, I abbreviated there, you take the degrees that you have and you multiply it by pi over 180. And that's the same thing that's happening here, it's just a little more direct. And then also, if you want degrees and you have radians, you take the radians that you have and you multiply it by 180 over pi. And the way to look at it is, when we want radians, we want to include pi. That's most often the case. Radians usually includes pi, so we want to multiply by pi and divide by 180. So we want to introduce pi into it. Over here, with degrees, we want to take the pi out, so we're going to end up dividing by it. So it's either pi over 180 or 180 over pi. Okay, it depends on which one you're going to. So the way I explain to students is, when you want radians, you want to include pi, so it's on top. When you want degrees, you want to divide the pi out. That's one way to remember it. But all you need to know is multiply by either pi over 180 or 180 over pi. So let's apply that. Convert 38 degrees into radians. So we have 38 degrees. So we're going to be using this one right here. So we want radians, so we'll multiply by pi over 180. And if we put that in a calculator, 38 times parentheses pi divided by 180. That will give us a decimal value of approximately 0.663 rounded. So we'll go with that. So 0.663 radians, I'll abbreviate, is the same thing as 38 degrees. Now convert 2 pi over 7 radians, so 2 pi over 7 radians into degrees. So we're doing that one right there. So this time we'll multiply by 180 over pi. And if you notice here, the pi's cancel, and 2 times 180, 360 all over 7. And we'll put that part in the calculator, 360 divided by 7. And we get 51.43 degrees. And if you notice here, we took the pi out when we went to degrees. We put the pi in when we went to radians. Alright, so let's continue on with the next topic. Alright, now for degrees, minutes, and seconds. You've probably seen this before, but not in a lot of detail, so let's go through it. Each degree can be broken up into minutes and seconds. These are angular measures, not time, although the analogy is certainly there. So 1 degree is 60 minutes, 1 minute is 60 seconds. So example 5 says, express an angle of 14 degrees, 57 minutes, and 32 seconds in shorthand notation. Okay, so degrees symbol is a little circle like that, and 57 minutes is 1 tick mark right there, and 32 seconds is 2 tick marks like that. So that's the shorthand notation. This is degrees, this is minutes, this is the seconds notation there. So 14 degrees, 57 minutes, 32 seconds. So if you see that on your paper, that's what it's referring to. All right, let's look at example 6. Okay, convert 123 degrees, 5 minutes, and 49 seconds into decimal form. Okay, so we know we have 123 point something, something, something degrees, right? We just need to convert this 5 minutes and 49 seconds here, 5 minutes and 49 seconds, into decimal degrees. So the first thing we'll do is we'll do a unit conversion. So 49 seconds, take that into minutes. So that would be 1 minute is 60 seconds like this. We want to divide the seconds out, so it's going on bottom. So it's equivalently 49 divided by 60. 49 divided by 60. 49 times 1/60 is the same thing as 49 divided by 60. So that's 0.81, I'm going to round, 0.817 minutes. So then we have this. We have 5 minutes, the original 5 minutes, plus another 0.817 minutes that we just identified. The 49 seconds, same thing as the 0.817 minutes. Now we want to convert this part into degrees, so that would be multiplied by, there is 1 degree in 60 minutes. If you notice, we're getting rid of the minutes unit and we're going to degrees here. So that would equal 5.817 divided by 60 is 0.09695 degrees. So altogether we have 123.09695 degrees. That's approximate because we did round. So 123 degrees, 5 minutes and 49 seconds is the same thing as 123.09695 degrees. All right, let's look at example 7 now. Okay, convert 238.458 degrees into degrees, minutes, and seconds. So we need this point. We know we have 238 degrees in our final answer, but we need how much is 0.458 degrees in minutes and seconds. Okay, so we'll do it this way. 0.458 degrees times 1 degree in 60 minutes, like this. So this time we're multiplying by 60. That's degree symbol right there, by the way. It's not 10. And let's bring up our calculator. I'm going to minimize this so we can see both. So we have 0.458 times 60 gives us 27.48 minutes. 27.48 minutes. So we now know that our answer is 238 degrees 27 minutes. Now we need to take that 0.48 minutes, and convert it into seconds. So that would be, we want to divide out the minutes and end with seconds. So that would be 1 minute is 60 seconds. So we're multiplying by 60 again. 0.48 times 60 is 28.8, so 28.8 seconds. And final answer is right here. 238 degrees, 27 minutes, 28.8 seconds is the same thing as 238.458 degrees. Okay, that's it for this video.